Hello everyone. A few months ago, Qualcomm announced they had bought Arduino, the inexpensive popular programmable board. Although they claim Arduino will maintain its open source ethos, if I had a nickel for every time a large corporation has reversed course, well, I'd have a lot bigger calculator collection. In a hypothetical situation where Arduino goes away entirely, I'll show you how you might be able to replace one with your TI-84 Plus CE using this, a TI-Innovator Hub. I'll prove it by lifting my entire body weight with this microcontroller that you can find used for about the same price as an Arduino Uno. However, the TI-Innovator has way more built-in features. We have 3 proprietary motor ports, a 10-pin digital I/O, 3 proprietary sensor inputs, a light sensor, I2C for connecting to a full rover, and finally, the port to connect to the calculator. The front has a few addressable LEDs and extra pins. For some reason, the pins aren't addressable by the calculator, so I won't get into those today. In addition to the rover, there's a lot of parts you can attach to the TI-Innovator, from motors to water pumps to scientific sensors. Unfortunately, the proprietary connection makes it difficult to interface with non-TI parts. So if I want to lift my body weight with this, I'll need to find a workaround. I'll keep the explanation on how to control the parts simple, since TI has already done all the hard work writing hundreds of pages of documentation. Essentially, it's just an extension of TI Basic. At the beginning of the program, you just tell the calculator what parts are connected to which port, then you can send part-specific commands to actually control them. If you install the Hub app, the calculator will even provide some templates that make coding much faster. Here's an example of how to get the vibration motor working. First, we tell the calculator vibration motor 1 is connected to port out 1. The documentation tells us the motor accepts values between 0 and 255, so we'll tell the vibration motor to set its intensity to 255. We wait for 2 seconds, then set the intensity to 0 to turn it off. What if we want to control a larger motor? The TI-Innovator can only power 5-volt motors at half an amp. Now I could build an elevator with hundreds of thousands of gear reductions, or we could just use a relay. A relay is perfect for us because it allows you to use a little bit of power to control a much more powerful circuit. You can see for this unpowered relay, the circuit travels through these pins. But when I power the relay, the circuit switches to these pins. This allows us to power this motor with a 9-volt battery. The relay in this circuit works very similarly to the transparent one I just showed. The circuit goes from the battery to the motor, then gets stopped at the relay before finishing back at the battery. How are we going to trigger the relay with the calculator though? Well, during my testing, I realized the proprietary ports aren't too complicated. They're just power, ground, what I believe to be its data return, and finally, trigger. We can trick the calculator into powering our relay by hooking up power and ground to the respective pins, then the trigger pin to the relay's switch pin. On the calculator, all we need to do is tell the calculator the relay is connected to the out 3 port, ask it to turn on the relay, and boom, we have a working circuit. I also found that if you want to power smaller motors without a relay, you can just do that on the breadboard ports. You get 10 digital I/O ports, 4 of which are PWM, and 3 of which also support analog in. You also get 8 ground pins, as well as permanently powered 3 and 5-volt ports. To show this, I connected a 10 kilo-ohm potentiometer to the TI-Innovator's analog in port. The calculator can read the potentiometer's resistance and return a value. So, we just connect the potentiometer to the breadboard port 5, tell the calculator we want a value from 0 to 100, then we just repeatedly check the potentiometer's value. Here I've mainly applied some tuning so the difference in pitch is more audible. Finally, we tell the speaker to play the tuned value. Now we can control the speaker's pitch using the potentiometer. This was pretty simple, but you can get way more complicated. TI Planet admin Critter wrote a converter that will let the TI-Innovator play music. This isn't a complete tutorial, but basically you just need to find a MIDI song you want to convert, use the TI Planet converter to get a string, send that string to your calculator, process the string using this program, then finally played the song using this program. So that's a lot of fun stuff you can do with the TI-Innovator, but how am I going to lift myself with it? I'll be using FlexiSpot's E7 Pro, which they kindly sent over and sponsored me to use the TI-Innovator to replace the control panel. For the past 2 years, I've been using this 36-inch desktopper so I wouldn't feel so lethargic sitting 8+ hours a day doing my day job. I slowly realized it wasn't a great fit for me though. It's slightly too short, too small to fit a full-size mousepad, and a little too cumbersome to adjust. FlexiSpot sponsored this video and sent over their E7 Pro to hopefully resolve all my issues without compromise. With the old desktopper, I did fix the size problem by making my own keyboard deck. However, this came at the cost of reduced stability and more difficulty raising and lowering. I love the E7 Pro is just as wide as my DIY keyboard deck, but more stable even at its highest point. It's also less prone to getting torn up with my projects, and effortless to raise and lower. I had to be careful with the old desktopper, because one day I leaned on it a little too much and accidentally tore off the keyboard deck. In contrast, FlexiSpot's dual motor 3-stage legs will confidently lift my whole body weight and hold over 3 times my weight at 440 pounds. The E7 Pro is giving me the freedom to upgrade my setup without fear of overloading. When I'm working on a project on the floor, the desk can lower to 25 inches for easy reach, but up to 50 inches when I'm doing my day job. FlexiSpot backs up their desk quality with a 15-year warranty and a 30-day risk-free return service. When you click the link down below to their website and use the code YTE730, you'll get $30 off the E7 Pro. This video wouldn't have been made without their support, so go check them out. Immediately after assembling the desk, I took apart the control panel to see how it worked. I was hoping the buttons would be simple resistive buttons. However, to make the panel more premium, it turns out the buttons are capacitive. It's a very similar technology to what your phone screen uses. For an end user, this is good because you can activate a button without applying any finger pressure. But it also means the control panel has more complicated circuits to detect a button press. I decided to probe the control panel's port to see what data was getting sent to the motor controller. But I didn't get very far before my probe slipped and shorted the 24-volt pin to one of the data pins. Unfortunately, I didn't get any footage, but imagine a sudden high-pitched scream from the onboard speaker with a tad of smoke. I knew immediately I had messed up big time. The controller was beyond saving. One aspect I'd like to see FlexiSpot improve on is selling replacement parts directly to consumers rather than needing to go through support. A week later, when I got the replacement control panel, I knew I had to change tactics drastically. Time was running out, and I couldn't afford to break another control panel. How do I trick the panel into thinking my finger was touching it? With a resistive button, you can just use force to press the button, but this approach doesn't work with capacitive buttons. My initial thought was to get a cheap stylus and use a servo to press against the panel. However, the servo was far too weak to make good contact. I considered using a much more powerful motor using a relay, but I really wanted a more graceful solution, and I wanted the calculator to be able to move the desk both up and down. I also tried this circuit by Leo's Bag of Tricks, but I didn't have time to fine-tune the circuit to make it work for my setup. With the deadline approaching, I decided to adjust my expectations. I didn't need fine control. I just needed to move the desk from the standing position to the sitting position and vice versa. I could do that much easier by using just 2 of the 4 desk memory functions. I covered one of the buttons with tape to provide much more sensitive contact. Then I took my servo and added a wire to it. If I hold one end of the wire and make the servo rotate so the other end of the wire touches the copper tape, the button gets triggered. For some reason, I was shocked when this actually worked, and the desk raised until my studio light hit the ceiling. All was well, and I knew I could do better than to just hold one end of the wire. So out of curiosity, I tried just connecting the wire to the entire roll of copper tape. I was shocked to find out that the wire now triggered the button without me even touching the copper tape. I'm just a computer scientist, so I couldn't tell you why this worked, but I was not about to look a gift horse in the mouth. I added another wire to the other end of the servo, then I edited the code to move the servo to the sitting button once the desk had reached its maximum height. This ended up being significantly less reliable than just making the desk move in one direction. The servo was completely not calibrated, so lining up the wire to press the sitting button was, in a word, I hit the wrong one. Challenging. I had to start the wires as close as possible to the copper tape without actually touching it. I then proceeded to try, and try, and try,
Another attempt. What?
and try again until eventually this happened.
What? You're touching.
So, the desk motors aren't designed for continuous adjustments for more than 2 minutes before needing 18 minutes of cooldown. During normal usage with this desk, I never encountered this error, but my repeated testing triggered the motor safety feature. Nevertheless, I now knew the setup could actually work. It was time to lift my whole body weight. After just a total of 21 attempts, I present to you Okay, I wasn't quite ready to call this a failure. I decided to edit the code so the calculator would press the down button again. If this worked, I was ready to call this a success. While it wasn't the clean up and down shot I was hoping for, I had reached the limit of my current setup. Frankly, I'm thrilled I got this working at all. So, after all this, could the TI-Innovator replace Arduino if it disappeared? I think as a learning tool, a basic automation tool, and testing tool, the TI-Innovator could absolutely replace Arduino. But for anything where speed or complexity is required, finding an alternative microcontroller is definitely your best bet. Remember to check out FlexiSpot's E7 Pro down below, and have a good day.